All right. Hopefully you guys can see the screen. Good afternoon or good evening. Thank you for joining today for this talk on Kotlin Multiplatform for mobile. My name is Karan Dhillon, and I am a software engineer working from Toronto for a company called Hootsuite, which provides a SaaS service for social media management platform. Today we are going to talk about Kotlin Multiplatform for mobile, what it is, and how to use it. Before I start explaining about KMM, let's take a quick look at our current stance and where we stand in the world of hybrid mobile frameworks. If you have been in the mobile development industry for a while, it's hard to skip all the hybrid mobile development framework gossip. In the past, a lot of frameworks came to the market that offered the opportunity to create Android and iOS applications via a single code base. The most notable candidates from this list are React Native, Xamarin, Ionic, and Flutter. You might
Sorry
have
to
at least
interrupt you,
heard of some of them.
Karan. Sorry to
So the
interrupt you.
question that we should be asking ourselves right now is why KMM? What makes KMM so special or game-changing in its own terms? In order for me to answer that, we'd first have to take a trip down the memory lane and talk about what these frameworks had to offer and in which aspects did they struggle to survive. Right out of the door, the biggest selling point for any developer lobbying the idea of adopting a hybrid mobile development framework has always been one code base. You'll hear the senior devs or whoever is preaching
Karan, can
about
you hear me?
hybrid mobile is how there is only one code base,
Karan, can
which
you
leads
hear me?
to time saved in writing code for two separate platforms. This also means bugs, which are inevitable, will become more visible as they'll start to happen more often, given they will propagate to each platform. And also, them getting squashed will be eventually faster. Everything associated with hybrid mobile development frameworks in the past has been fast. Developers, after making themselves comfortable with the framework, they write code fast, they locally build code fast. An example being the hot reload feature in Flutter. They ship code fast, and the product ultimately reaches production and in the market faster. Please note that all of this is in comparison to the time spent in making the same product in both Android and in iOS combined. That is one of the reasons why companies who do not have native applications for their projects are so attracted to these frameworks, almost like a moth to fire. Needless to say, if there are ups, then there are downs as well. If adopted, then the project is bound to the framework. You cannot simply use libraries targeting native implementations as they won't work. And you would have to either look for some popular package in a registry like NPM or a community provided solution. Also, the greater platform specific controls that you have while working on a platform native application, those are missing in this case. Another finding so far that has been pretty evident from the adoption of hybrid mobile development frameworks has been its nature of how it fragmentizes when the code base starts to get bigger. It is not easy to write instrumentation tests on a single code base, which is supposed to satisfy multiple platforms. Also, whenever a same feature, for instance, altering how errors are rendered in UI upon login, needs to be implemented with different behaviors on each platform, developers often have to resort to some mechanics which makes them less confident in the overall project structure. Now, the question remains to be answered. Why KMM? Why JetBrains is taking it upon themselves to write a hybrid mobile framework? The answer lies in two aspects: the market share of Android and the language which Android apps are built upon. According to IDC, Android market share is at 85% in 2021, with projections up to reaching 85.7 in 24. JetBrains, when compared with past framework owners, has an upper hand in creating a hybrid mobile framework due to their relationship with Kotlin and how Kotlin is the primary language when it comes to creating Android applications besides Java. Given these facts, it's a natural assumption that any Android developer, if given a chance to choose a hybrid framework, would naturally incline towards KMM as there is no overhead of learning another language, such as Dart. So to follow that, on August 1st, 2020, Jabris released 0.1.0 version of Kotlin Multiplatform Mobile Plugin. That is the requirement to create cross-platform mobile solutions with Kotlin. But from a user perspective, it doesn't really matter to us what language that framework demands. Sure, there is less overhead of learning a new language if we have to go with another options, but our priority as developers or as stakeholder in the project is how well we can utilize the framework to make and ship features, and how well it solves the problems mentioned initially. That is exactly where KMM shines. Previous frameworks, in my honest opinion, try to do too much at once. And by that, I mean they try to provide you, along with the framework specific libraries, with a public API to write the presentation data layer. And the team can then come up with any design patterns to link their business logic into this. Working in a project that is tied to its framework is ideal, as long as you're willing to make the trade that you will stick with the framework through all of its ups and downs. Kotlin Multiplatform for mobile, on the other hand, doesn't do that. KMM understands that there are certain discrepancies between iOS and Android, so it tries its minimal to force the developer in that sense, and allows the both platform teams to write their business and data logic once, while giving the option to handle any of these discrepancies in any way the platform sees fit. Needless to say, one can argue that more often than not, data layer implementation is also something that is not totally platform agnostic. However, KMM smartly offers the same solution that it provides in handling the differences in the presentation layer. The libraries underneath use the same solution to create platform-specific drivers while providing a platform-agnostic dependency. And that solution is expect actual paradigm. One often says that sometimes the simplest solutions are the best one, and that is totally true in this case. One code base does not necessarily mean that there should only be one code to solve a problem. Though on surface, the problem might be the same, its implementation based on the platform could differ significantly. That is why KMM allows you to mark your contract with an expect keyword. This is to notify the Kotlin compiler that this contract is marked with expect, and hence the platforms must satisfy this condition by providing their own actual implementations. For example, let's assume you're writing a feature where you have collected the user information, and now you have to store this user into the database. In order for you to do that, you have to generate a unique identifier. We could utilize a standard Kotlin library to do that. But on the flip side, we could also leverage the platform-specific libraries that are already there to do this job. All we have to do is mark this requirement with expect and keep it abstract. One condition that you should remember is that any element, regardless of it being a class, interface, function, or a member property, marked with expect would be abstract. And that is simply due to the fact that we are instructing the Kotlin compiler that in order for it to resolve this dependency, it would have to look into platform-specific directories and locate the same element, but marked with actual keyword. Then for each platform, we provide the actual implementations by marking the function with actual keyword. Notice how we utilize the platform-specific libraries in both of these cases. One thing that I need to make clear is that these actual implementations for a platform live in their own subdirectories, separate from the directory in which store your expect elements. To make it clear, let us take a look at a typical Kotlin multi-platform mobile project. Though our discussion will only be limited to Kotlin multi-platform for mobile, you should know that this is not limited to mobile only. Kotlin compiler is currently being rewritten entirely to support Kotlin IR. This new compiler will take your code, turn it into an representation, and forward it to the platform-specific compiler. So for JVM, Kotlin JVM compiler will trigger and henceforth. They already have made much progress in this regard, and any new download of Android Studio from 4.2 release candidate 1 will prompt you to enable this compiler by default. When you create a new project, your directory structure will look something like this. Android app and iOS app modules are standard business as usual. You will see the directory structure for these modules are what you as an Android or iOS developer expects. The most important module from KMM perspective is this shared module. All of your expect mark element files will live in the common main directory inside this module. All of your business layer logic will also live in the common main directory. This is a good test for you if your project claims to be following clean architecture. You can simply drag and drop the business logic into this common main directory, and it should work right out of the box because there are no platform dependent dependencies in clean architecture business layer. Shared module has directories for each platform that you are targeting. The directory naming pattern is pretty standard as well, which is the name of the platform plus the source set it's targeting. So let's say you want to provide an actual iOS main source set implementation, it will go in iOS main directory. If you want to provide, let's say, actual Android unit test source set implementation, then it will go in Android test directory. So with this combination of platform plus source set, you have the power to separate different implementations that you provide for your production and your test cases. This was something that was really hard to do in previous hybrid mobile frameworks. KMM makes it really easy to understand what kind of code lives where. When adopting KMM, your main goal is to put as much code as you can in the common main module. If you want to convert an existing project to use KMM, your first step will be to simply drop everything into the common main module and then start fixing what needs to be fixed. Common main module is where your business logic will live. That is your use case, your entities, and your repositories. You can even save your data layer logic here with the help of libraries written for KMM that provide different implementations for different platforms, which we will see how to do that in the later section. So let's say while you're putting code in common main module and feel that certain bits cannot be stored there because they are platform dependent and they require different implementations based on the platform. Now you know what to do. You simply mark that bit with the expect keyword, you make it abstract, provided the actual implementations, which would go in their platform-specific directory. So for Android, that will go in Android main, and for iOS, that will go in iOS main. To sum up this slide, put all the common code in the common main, put all the expected marked classes in common main as well. Put all the classes marked with actual in their respective subdirectories. Now we will go over a small project called SpaceX, which demonstrates how to work with KMM. We will implement caching and networking strategy in this project as well, as they are almost present in all of the applications out there. In order for you to use KMM, we have to follow certain requirements. You need to be on either the experimental version of Android Studio, which is release candidate 1.4.2 right now, or you can even go ahead and get the Arctic Fox Canary version. Both will suffice. If you're going to write iOS-specific code, then you will need Xcode version 11.3 or higher. This will naturally indicate that this means you need to be on a MacBook or a Mac OS powered device. This is just an Apple limitation. If you're good for now, the next step would be to install the compatible Kotlin compiler plugin. You would also need to go to Android Studio Preferences and install the KMM plugin from the marketplace. And last but not the least, you need to have the JDK installed on your work machine. Android Studio does come shipped with an embedded JDK, but if you want to use OpenJDK, you are free to do so as well. Once you have the KMM plugin installed in the Android Studio, simply go to the new project, choose the KMM application option from the menu. KMM by default creates iOS and Android modules with Android app and iOS app as their names respectively. But once created, we can go ahead and configure to add new modules for other platforms that can be dependent upon the shared module. Our final project structure will look something like this. Shared module is going to hold the common code with expected marked classes going into the common main directory and the actual marked classes going into their respective subdirectories. Android app and iOS app modules are where our final production applications will be built upon. As this shared modules from Gradle's perspective as a library module, Gradle provides a build script for this module as well, which we will utilize now to add the KMM dependencies. The first dependency we are going to bring in the shared module Gradle script is Kotlin coroutines. Coroutines is our solution for now to handle async work in the project. So under source sets, we define the coroutine dependency in the common main directory. This means it will also be available to, let's say, an Android main or iOS main subdirectory. Networking is a crucial part of most of the mobile apps out there. Receiving payloads and converting them to syntactic entities for the language you're using is handled by various libraries out there. such as JSON or Moshi. Kotlin serialization is our choice for KMM. However, before we include the dependency, we have to include its Gradle plugin to the class path. So we go into the root Gradle build script and add the Kotlin serialization Gradle plugin to the class path for the Gradle to find it. Once the Gradle plugin is installed, we apply the plugin and include the Kotlin serialization dependency in the shared modules build script. Android developers are familiar with OKHTTP, which is the go-to library for an HTTP client. Ktor is pretty similar. Despite bringing in the core dependency for Ktor, we also have to include Ktor client serialization dependency. This simply instructs Ktor to use Kotlin X serialization that we just imported. We also have to add platform-specific engines for Ktor to work on different platforms. So we go ahead and import the two dependencies in the common mesh source set. For platform-specific Ktor drivers, we open their respective source set and import them there. In our case, we include iOS and Android drivers as shown above. Last but not the least, caching or local storage is also a crucial component in making an application. We do not want to waste battery by making the same number calls again and again, and we can store the result locally and retrieve it whenever we like so. SQLDelete by Square would be our choice to do the local storage. First, we store the version we are going to use for the SQLDelete library in Gradle.properties. You can store this anywhere you prefer. Next step, just like Kotlin serialization library, we add SQLDelete plugin to the class path so that Gradle can find it and use it. And at last but not least, we bring in the core library along with platform-specific drivers. Much like any other serialization library, Kotlin X serialization works on the same principles. Here we have three entities: rocket launch to give us info about when and where the rockets were launched, rocket providing the ID, name, and type of the rocket, and finally links for embedding certain links into the model. By marking an entity with serializable annotation, Kotlin X serialization plugin automatically generates a serializer to deal with these classes. We also have the option to provide our own serializer in case if we need to do so. More often than not, the default serializer is good enough. Serial name helps in indicating the field name in the remote payload from which the value and be extracted upon from the associated field. We need to configure the SQLDelete library and instruct it by providing two key pieces: the name of our database and the location where the auto-generated Kotlin sources will be placed. This will get a bit clear in the next step. This is simply telling the SQLDelete library that it has to find a file called appdatabase.sq in a default folder called SQLDelete. So we create the SQLDelete directory in the common main and create the path we mentioned in the last step by setting the package name field in the Gradle config. Next step would be to create the appdatabase.sq file, and the app database name is important because that's what we told the library to look up for in the Gradle config. Inside appdatabase.sq, we can throw all the SQL queries that we are interested in. Most commonly, these SQL queries are CRUD functionalities on the tables. These tables did not have any associations with the entity classes that we created before. As you'll see shortly, SQLDelete auto-generate files based on these queries for us to have them in our Kotlin code base. Here we are creating our tables in the database. Here are the SQL queries to add data to the table. Here are the insert and delete queries. Here are the select queries. So this is standard SQL. We can write any query we want and choose whatever column we'd like to do so. To quickly recap, we created a SQ file with the same name we defined in the Gradle config, and we placed it in the SQLDelete directory that we created in the common main. We also created a package directory structure as defined in the Gradle config, so SQLDelete can place auto-generated classes in that package directory. Upon compiling and building the project, you will see that SQLite has generated some interfaces and classes for you. This, being an auto-generated code, goes into the build directory. However, it is still accessible from your code, much like how Dagger or any other autogen component works. Up until now, SQLite has saved you the effort of writing all of this boilerplate. Let's look at some of the auto-generated classes as we are going to use them, starting with app database interface. First thing to note is the member property called app database queries, which we will also look at later. This is simply all of the queries we define in our app database SQ file, but via a Kotlin API. There is a handy companion object called invoke, which can be called to get an instance of app database. As we know, SQLite has platform-specific implementations for Android and iOS. Therefore, in order to create an instance of app database, it requires a SQL driver object, which we will create soon with the help of expect actual paradigm. For now, let's take a look at app database queries interface that was generated for us. As mentioned, this interface simply generates the same SQL queries, but exposes the Kotlin API so that it can be called into our Kotlin codebase. Because a SQL driver is required to create an instance of app database, we are going to create a SQL driver factory. We know SQL driver is based on platform, so we mark this class with expect keyword, and our Android main and iOS main will contain the platform-specific implementations. Your compiler will issue an error when actual implementations are not present in your platform. So you can kind of say that this works similarly to how abstract keyword works. Not exactly, but kind of. Next step, as expected, would be to create the platform-specific implementations for Android and iOS. Notice we are in the Android main directory. We create the same class, but mark it with actual. Similarly, we go into the iOS main directory and provide the same class implementation, but mark it with actual. Now the platform can provide their own implementations of a SQL driver instance, and we are good to go to create an instance of app database. We have the database driver factory, which will spit out platform-specific SQLite drivers, and in turn, we have our platform-specific database implementations. One final step from local storage strategy perspective would be to create a wrapper database class. This will simply accept the database factory as one of its arguments. Even though database driver factory is marked with expect, we know that we have provided the actual implementations per platform, so we are good to go. Upon making the call to create the SQL driver, if we are on an Android platform, Android's factory implementation would kick in. And we will be able to create a SQLite database on Android by passing the context to it. Similarly, if you're creating a driver for iOS, then iOS native factory implementations would provide us with the required driver. From implementation perspective, we are not concerned with that. We have delegated our responsibility to the database driver factory class. We also restrict our database visibility with internal so that only code within shared module can use it and iOS app or Android app modules cannot read it. This is to not lead the low-level implementations to our higher-level app modules, as they shouldn't be concerned with how caching or local storage is being done. Now that our local storage is set, next part is to work on our networking strategy. In order to make sure we are grouping files correctly, we can go ahead and create a network directory in the shared module. This is, of course, optional, but highly recommended. Our networking strategy is pretty straightforward. We provide the base URL and launches endpoint member property. We create our HTTP client and instruct it to use Kotlin Next serialization. This is pretty similar to how we create an OK HTTP instance via the builder pattern. Also, as a running joke in the Android community, do not forget to add the internet permission in the manifest by going into the Android app module, or you'll receive a runtime exception when you will build and run the project. One last thing in shared module left for us to do is to follow the facade pattern and hide our caching and networking logic under a class called SpaceX SDK. This class has the database and the network API as its member properties. Our code can call the public API to first get the results if they are already cached, and if not cached, then make the network call and cache them later. From Gradle perspective, shared module is simply a library module. So we open the Android apps Gradle build script and include the shared module in it. Inside our main directory, we create a coroutine scope so that we can achieve structured concurrency. If we need to cancel the jobs, we can cancel them via the scope. Next step is to bring the SpaceX SDK from the shared module. Notice how we are passing the database driver factory instance in it. Because we are in the Android app module, Kotlin compiler is intelligent enough to give us the Android-defined actual marked database driver factory, to which you can pass the context. Last thing left for us to do is to launch a coroutine. Call the getLaunches method in SpaceX SDK, which will automatically cache and make the networking call for us. I'm going to skip the UI logic implementation, as on Android that can be done via Jetpack Compose, and on iOS that can be done via Swift UI. That is out of the scope of this presentation, and anyone interested can read about them, as there are tons of resources online about how to write declarative UI. Notice how the two UIs on both platforms is not eerily similar. This is because KMM does not try or has any intention to force UI classes onto your project. Where KMM wants to shine is how business logic is shared among two different platform teams. Notice that we saw the demo on how to create a project in KMM. We should also look into some of the challenges that KMM is going to face. First is KMM being in alpha. The public API is expected to change given its scale, so deploying a KMM project in production would not be easy for a small team right now. Also, a lot of edge cases might be encountered when working with KMM. For example, how one is going to manage sensitive information in their KMM projects. Developers might have to wait for a bit for a library that will be battle tested and safe to use. Another challenge is how KMM integrates into the shared module in the iOS project. Currently, it takes the shared module and adds it as a framework full of Objective-C classes. Debugging these classes is not easy and would require Objective-C knowledge from developers' part. Having them in Swift would be ideal case, but it is not a simple task, as there are certain language constructs that are not present in Objective-C. If you or your team is looking for a hybrid framework solution, now is when you're contemplating if KMM is the right key to going hybrid or not. My personal answer is yes, it is the key. I cannot say that KMM will be the final solution in this. There will be a case in the future, or there could be a case in the future, that another framework comes and takes into account what KMM has done and builds on top of that. If declarative UI goes prominent, then providing a single public API agnostic of platforms could be an ideal case for a framework to replace KMM in the future. However, with all that said, KMM is approaching hybrid solution from a different direction. In the past, frameworks took crack at the issue by providing everything, including UI layer solutions, and external dependencies for network or caching layer. KMM, on the other hand, is more focused in managing your business, data, and network logic. For now, with the expect actual paradigm, KMM is delegating the responsibility of writing any code that one feels cannot be shared to the user. This ultimately gives you more room to breathe and doesn't force you to share every single last bit of code. For anyone who was looking for good resources to start in KMM, actual documentation would be the first step you should visit. And you should also check out the new playlist for KMM at YouTube on their official Kotlin YouTube channel. If you would like to reach out to me, I'm always active on Twitter. And if you would like to get a handle to these slides, they can be found on my blog post. So that is all from my end. Thank you so much for your time today. And thank you for being here.
Thank you very much, Karan. I feel like this is super bright. Oh, there we go. Thank you very much for the talk. That was very informative. As somebody who has been doing a lot of Flutter work, multi-platform is definitely a hot topic. Every manager's dream. We have some questions. We have a question. Would you like to field it?
Yeah, sure. So Rahul asks, can we use retrofit room shared preferences when working with KMM for the Android part? So if your solution is to use them for your data layer, then the answer would be no, because retrofit room, they're made for they need native implementations, and that is not going to cut the case with KMM. You can use retrofit and room or shared preferences in the Android app module because you can do anything over there. But if you want to have your data layer and your caching or local storage solution in the shared module, then you cannot bring any platform dependent libraries in that module. So any library that's going to do this caching or local storage has to be platform agnostic. And currently, the most widely used one is the one that was demonstrated in the project, which is SQLite. The way they handle this, they hello?
Oh, you froze off there for a second. Can you repeat the
Yeah, I can repeat it. I was saying that SQLite is the library that is being used mostly in KMM world right now, and the way they provide the solution to be platform agnostic is by using these platform specific drivers, as shown in the demo. So, short answer, you cannot, not in the shared module.
No, that's definitely a good point. I mean, definitely going cross-platform, you have to take into consideration other platforms. Like everybody knows, iOS uses Swift and Objective-C, and Android has Kotlin and Java. So keeping it generic is really the main idea here. But definitely, thank you for that well-detailed.
Thank you, and thank you for to you guys as well for organizing this.
Yeah, thanks for coming on board. We got another question. Would it be possible to hide retrofit via expect/actual? From Gabor.
Wouldn't it be possible to hide retrofit by expect actual? I'm pretty sure you can do that if you use expect actual paradigm in like a smart, intelligent way. For sure, you can do that. You can drop in an expect class into your shared module, and your Android app would pick that, and you can pick that up via the actual implementation in Android app module. Not exactly sure what you will do in the iOS side. I guess you would have to use their own library that is evident in iOS development. So I think what Gabor is trying to suggest is you can come up with a sort of facade, like abstract interfaces. You can create these dependencies, but I don't think you can directly bring in retrofit and use that in the shared module itself, because your iOS code is not going to pick that up. Another question is, Robert A. Henley, have you seen any example of how a KMM project can be used to build a Flutter plugin? Unfortunately, I have not seen any example of that. I have seen a lot of KMM projects examples. Specifically, I've read a lot of projects by John O'Reilly. So yeah, haven't read a KMM project that uses Flutter plugin. Would love to do so.
I don't know if those things really gel. I don't think you would want to or need to mix KMM with Flutter. Like Flutter, ideally with Flutter, you implement as much as possible in Dart, right? Like I think a lot of people confuse Flutter for being kind of like a UI framework, but you can do everything with the exception of anything that kind of needs native integration in Flutter. So you can do your network requests. You can even store persistent data and that kind of thing. there are hooks to the native OS, but it's all done using native code. So I guess that is the point. You could make a Flutter library that uses KMM and then maintain the separate. Wow, blowing my own mind the more I even think about it. That'd be really interesting. But I feel like there's so much with these types of platforms. There's so much scaffolding around kind of getting what you would assume to be kind of basic working, right? It's like SQLite's great. It's fantastic. But there's, I feel like even just code generation to some people is a lot, right? Do you find that, have you found any limitations so far with your testing or your work rather, where there's something that you wish kind of worked in KMM that is either not just completely non-existent or too alpha to really count?
I haven't found any limitations so far, just because how KMM allows you to create a platform-specific subdirectories, and the fact that you can even have directories within platform based on the source set. So personally, I haven't had any limitations so far. I know SQLite is being used a lot, but Realm also introduced their own library for KMM. A lot of people are interested in that as well. So just because there's a lot of active development going on, and given the fact that it's still in alpha, I'm not sure there's like a massive. I could be wrong here. I'm not sure if there's a massive project out there that's already in production. And there could be apps that are using KMM. I know Netflix is using KMM in their app, so maybe that is something that one can read. But in my expertise of how much I've used KMM, I still haven't found any blockers so far.
Right. Yeah. I mean, it's very similar to Flutter, right? Where ultimately, if you need a native implementation, you just code it in the native language and create the interface to allow you to access that implementation.
Mhm.
I don't want to keep bringing up Flutter like I'm some sort of shill, but they are paying me to say this. So, yeah.
I actually do have a question, because I think one of the key things here, that with anyone dealing with cross-platform, they always have this kind of level of resistance where it's like one person will actually be able to do it, aka in this case it's Kotlin, so it's Android, and iOS won't really be able to contribute to their full extent. With regards to collaboration, what's your take on that? Have you had to work with some iOS counterparts? What have you heard from that side, so that we can kind of get a sense of what will happen if we get more of a cross collaboration approach going?
So we at my current company at Hootsuite, we did have this as a prospective agenda that we're gonna and have go to the hybrid part with KMM, and there was a commotion where iOS devs were concerned they have to forget everything they have learned and they have to like pretty much start from scratch. But honestly, that is not the case. Sure, you would have to learn Kotlin, but if you already know Swift, it's not a big difference per se. Both of them are model languages for two of the major operating systems out there for mobile. So they are in some facts really similar. So wouldn't be that big of a jump. I think what you need to, as a manager or someone who's going to lobby the idea of KMM into your teams, you have to champion the fact that you have to prove the benefits to your iOS team. You have to, the biggest benefit you have to show them is that you're going to share your business logic. And the the amount of flaws, the amount of bugs are going to be less. The amount of time it takes to triage a bug and fix it is going to be less, because there are going to be more set of eyes on a single piece of code base. So you just have to write down all the plus points. You have to make sure that you understand them well, and you have to make sure that it is upon you to guide the iOS team and tell them how things are going to work in the KMM world.
No, you're absolutely right. I'm sure the iOS team will do the same to Android any day now, if there was
I,
a Swift equivalent.
I love that idea. Listen up, you iOS devs. Here's how it's going to work. We all know that iOS and Android devs get along like peanut butter and jelly, baby. Okay, I think that's it. I didn't mean to end it on that note, but thank you so much again.